we are Advanced Combustion Hot Air Balloon Engineering Project. Our project is advised by Dr. Derek Dunricken and Dr. Alice Chen. I'm Lily Nguyen, the team lead.
Hi, I'm Anthony Grayback.
Hi, I'm Ibrahim Afik.
Hi, I'm Ivan Macias.
Our research and development project all started with a graduate student's research. Her father owned Ultramagic, a hot air balloon burner company. Her study was based on the heat transfer within a hot air balloon. However, throughout history, there are no formal studies done on the efficiency and performance of a hot air balloon burner. So that is what we are focusing on now.
So the main goals of the project is to first design, then build a testing facility that will allow us to test the emissions and efficiency that's coming from a hot air balloon burner. The main objectives is to first provide the testing facility and then allow for us to use it to test hot air balloons in the field. And then we can increase the combustion efficiency of those hot air balloons and increase the fuel economy. And lastly, we want to engage undergrad students into doing research and development to allow for easier transition into the industry.
As most projects, there are numerous components that must be integrated together to form a system. Due to this nature, this required our team to be divided into proper sub-teams. Within those sub-teams, we have a duct and fan team, and we also have a fuel and emissions analysis team. For the ducting requirements, it had to withstand the hot temperature emissions coming from the burner. It had to be resistant to corrosion, and the current configuration requires students to climb up a ladder such that there's nowhere to put harness clamps. Therefore, it's unsafe. So the objective of the ducting system is to allow for safer sampling of the emissions.
And for the fan system, it should maintain the flow rate that's coming from the emission from the burner, and also it should allow for more convenience when sampling using the anorak. And finally, the fan should not interfere with the sampling and have minimal to no effect on the results.
The significance of the fuel and emissions subteam is to design any components that are related to the propane fuel or the gas analyzer, the Anorak 700. Our components are the testing methods, gas analysis, time delay, rate modifications, mass flow rate, and the probe attachment. Testing methods are the experimental procedure that we conducted this quarter. It was modified with our new semi-enclosed testing rig that was modified this summer. It is compatible with the Ultramagic 3.2 megawatt burner and our Anorak 700. The gas analysis time delay is a system designed to output gas emissions and efficiency in real time. Currently, there's an average of an 8-second delay in all the different gases like NOx, carbon dioxide, and oxygen output at different times. We aim to have the Anorak output data once the combustion reaction starts. The rig modifications allow for a safer placement between the burner and the propane tank. Right now, the burner is 2.2 meters away from the tank, and the tank can reach an ambient temperature of 125 degrees Fahrenheit, which is very hot and very unsafe.
So the purpose of the mass flow is to accurately measure the amount of propane exiting the burner. So our requirements to develop such procedures to monitor continuous mass flow, it should be digitally monitored, and it should have a sampling rate of about approximately 100 milliseconds. So in order to measure the concentration of the exhaust, we needed to develop a probe placement mechanism. So the device for this probe placement needs to have a clamping system. It needs to be vertically extendable from about 10 to 20 feet, and then it also needs to be structurally stable. In regards to the timeline, it's divided by quarters. So in the fall quarter, it's all about design and research. So this quarter, we researched and designed the components required to form a testing facility. In the winter quarter, the next quarter, is all going to be about fabrication and evaluation of our design. We'll make adjustments as required. And then finally in the spring, it consists of validation and application of our testing facility. We're aiming to use our facility to evaluate the performance of the burner, We'll also be able to effectively measure emissions from real hot air balloons using our field probe placement.
For our current progress, we have managed to develop the design of a duct and fan system that meet the requirements previously discussed. We have also been successful in designing a permanent burner mount that will allow us to fix the burner to the rig. We have also designed a mass flow rate procedure. And finally, we have designed a preliminary probe placement device, as previously mentioned, that will allow us to test emissions from real hot air balloons, in which we will also be able to compare that to the emissions we get from our testing facility. And for a quick summary, our future goals are to manufacture and build our proposed designs. Upon completing the assembly of our testing facility, we hope to run experiments trying to determine the optimal conditions for efficiency and emissions. And once we make significant discoveries, we are aiming to share them around the world with hot air balloon users in an effort to, 1, increase air quality for everyone, and 2, increase fuel economy for the users.